Recording will start soon. We were here, the infix and postfix forms, right? So, anybody has any questions on this form, infix, prefix, postfix, etc., please feel free to ask. And one of the important aspects that we studied about prefix, postfix is that you don't have that ambiguity and you don't need the parenthesis to be there. And we wanted to start the class with understanding how to convert this infix to prefix, postfix, right? And therefore we'll start the class with that table of classwork. But just look at these expressions once. The order of evaluation should remain the same, right? Whatever you want it to be, right? So the BODMAS should get encoded automatically in the expression itself, which is not there in the infix form. I don't know if star should be evaluated first or plus should be evaluated unless I give some additional information about precedence. But in case of prefix and postfix, the order of evaluation is fixed, and that is what we would like to do in this particular table, right? So for each of these expressions in your copies or somewhere else, please write down the prefix and postfix forms. Do not write it in the chat. Maybe I'll disable the chat for a moment because I want everybody to try this out. So for a moment, I'm going to disable the chat. Please try this out yourself and let me know if there are any questions. Yeah, sorry about the noise. There's some construction going on nearby. By the way, a general rule based on Abhishek's question is that if we are the one who are allocating memory, we should be deallocating it. If we have not explicitly allocated memory using new or malloc, then we don't have to worry about deallocation. So that is the general rule. But yeah, there are exceptions to this. There are some pointers which can be temporarily allocated on the stack, and those can be deallocated automatically. But yeah, we'll not go there. All right, so maybe I'll enable the chat at least for the first row. Yeah, so what is the prefix form of the first expression? Okay, Mrityunjay says star plus 1 to minus 3 4. Saicharan says the same. Pavan says the same. Rishabh says the same. Okay, so so that seems to be reasonable. Let's check that quickly. So since 1 plus 2 needs to be evaluated, and that should be evaluated first, it will get converted into plus 1 2. That part is okay, and this will be minus 3 4. Now that star should be evaluated after 3 minus 4 is done, and therefore star should appear on the left of the two arguments. The two arguments should be plus 1 2 and minus 3 4, and therefore the expression becomes what is suggested by our friends. Okay, so that is the prefix form. The postfix form should also appear very similar, just that now it will appear in the opposite order. So, okay, I think you guys have already written. Shania has written 1 2 plus 3 4 minus star, and Aniruddha says the same. Saicharan, Pavan says the same. Anand says the same. Murari says 3 4 minus Murari. Yeah, Rishabh. Rishabh says 4 3 minus. Why is that? No, so again, the order of the operands, this 1 2 3 4 will remain the same in infix, prefix, postfix. Only the operators' positions are going to change. Right? Okay, so Andreas is the same. Yeah, Murari has corrected that. Okay, good. So yeah, so that seems to be okay, and I hope some of you have gotten it. Again, please try this out for the second one. I'm going to disable the chat again for some time, or maybe I'll keep the chat open, but don't answer the second row unless I give some time to everybody. All right, so please try the second one. What will be the prefix? And the postfix? I mean, if you notice in this case, the not only the operands but also the operators remain the same in the infix form. Only the positions of the parentheses are changing, right? So it is 1, 2, 3, 4, and then there are plus, star, and minus having their positions exactly in that order. It's just that how we parenthesize the expression that is changing, and because of that the prefix and postfix are changing, and that is a very good sign that prefix and postfix are probably able to disambiguate how the order of evaluation should be. We cannot do that without parenthesis in the infix form. Okay, so this will be a good time to tell what will be the prefix form for the second row. Okay. There are a lot of messages and my reading speed is low. Okay, plus 1 star 2 minus 3 4. That is repeating. Okay, okay, great. There is a large consensus. There is a small Mani Chandana is saying plus 1 2 star minus 3 4. Okay, yes, corrected that. No problem. That's fine. We are allowed to commit mistakes. That's called freedom. Okay, so yeah, so let's understand how this needs to be done. So as you go to 1 plus, I cannot evaluate it unless I have done all of this, right? When you talk about 2 star, I cannot finish that unless I have 3 minus 4 completed. And therefore in the prefix form, minus 3 4 has to appear together. After minus 3 4 is done, that needs to be multiplied with 2, where 2 is the first argument, and therefore star 2 and then minus 3 4 is going to appear, right? After this there is going to be plus 1 star 2 and minus 3 4, right? So plus 1 star 2 and minus 3 4. Shania has already given the postfix form. Okay, so now we can have the postfix forms evaluated. But if there are any questions on the prefix form, please ask. Uh, on the prefix form of any of these, please feel free to ask if something is unclear. Okay, there is large consensus on the postfix, right? So as you can see, in all of these answers, 1, 2, 3, 4 appears exactly in the same order: infix, prefix, postfix. Okay, and then minus, star, plus. That is the order in which that should happen. First minus, then star, and then plus. Right? So that seems to be good. And since these are always appearing on the right hand side expression, I mean, this is kind of right nested expression, and therefore all the operators are appearing on the right hand side. Okay, sounds good. Thanks a lot for all these answers. We'll do one more, and then I think we'll be able to you'll be able to figure out how to do that. So let's take the third one. What will be the, so please spend some time thinking about what will be the prefix form of this expression, third one. And after a few seconds, then we will ask you. Meanwhile, if you are fast, you can finish the other prefix and postfix. I'm going to show also the answers. Okay, there are already answers. minus plus 1 star 2 3 4 minus plus. Okay, great, thanks a lot. So all of you seem to be giving exactly the same answer. So let's see. So we have 2 star 3 should get evaluated first. So it will become star 2 3, and then before we apply minus, this all of this expression should be over, and therefore it will become plus 1 2 2 3. Sorry, this we are talking about prefix, right? So plus 1 star 2 3, and then after that I am going to do minus with 4. So this was the first argument, so minus will appear on the left hand side of all of this that we did. So minus plus 1 star 2 3 followed by 4, minus plus 1 star 2 3 followed by 4. Okay, great. And then there are postfix forms also specified, 1 2 3 star plus 4 minus. Okay, so let's see that. Okay, so again in this case 1 is not going to be added to 2 directly. We need to do 2 3 star first. So 2 3 star happens, then that is preceded by 1 and followed by plus, then that is preceded by no, then after that 4 appears and then minus, right? So this is going to be 1 2 3 star plus 4 minus, 1 2 3 star plus 4 minus. Yes, okay, great. So all of our answers are matching, and that's a good sign. Any questions so far? Right, so these are the answers that you should be getting. If in case I have made a mistake in any of these, please let me know. All right, so that is good that we are able to disambiguate. There are no parentheses, etc. But then only representation is not going to be very helpful, right? So we have the representation, but now we would like to evaluate also. If I have to evaluate, should I convert it back to infix and evaluate? It will be very nice if I can have this expression 1 2 3 star 4 minus plus something like that, this last expression, and I'll be able to evaluate it directly. That will be very nice, right? And that is where our data structure stack is going to help us. And let's see how to do that, right? So okay, let me ask you, how will you do that? So please spend some time thinking about that. You are given this expression, right? Assume that it is all digits, integers, and then plus minus star slash, right? All of these operators are present. Now you want to evaluate this expression. How will you evaluate this? So please think about it, develop your algorithm, and then we can have a discussion. If there is any thought which is blocking you, if there are any questions, please feel free to ask. Right? So what I want you to do is to, given a postfix expression, how to find its value. For example, in this case, the last value is 6 minus 4 is 2. So 3, right? So I would like to get the value of this expression to be 3. Right? How do I do that? Okay. Okay, Murari says before that converting infix to prefix postfix, this also can be done in stack. Yes, it can be done in stack. That is correct. That is conversion of infix to postfix. Can that be done using a stack? Yes, I think I will have some slide on that. But if not, yes, it can be done. Dilip says iterate through the expression. If you encounter a number, add it to the stack. If it's an operator, then take the last 2 elements in the stack and do the respective operation. And and do what? There is something more small part missing there. The logic is algorithm is correct. There is one small piece that is needs to be added.
Remove the last two elements and add that result.
Remove the last two elements and
Add the result to the last.
Put result in the stack.
right. We have to put back the result, right? So good. Okay, so that is the correct algorithm. Nikhil Anand says go term by term. When you see an operator, apply it to the last two elements and remove those elements, add the result to the stack. Correct. Kaustubh says take an operator and if the preceding two characters are integers, evaluate the expression and replace with that with an integer and repeat. And I don't know about the else part. What happens if the last two characters are not integers? What happens, Kaustubh? Just keep appending to the stack. I see. Okay. Okay. Right. So this is different from what the earlier suggestions were, right? So earlier suggestions were saying that whenever you encounter an operator, you are guaranteed to have two operands. I mean, assuming that all these four are binary operators, you are guaranteed to have both the operands available on stack. Whereas this suggestion says that if those are present, then you do. Otherwise, you just keep appending it to the stack. Okay, so that's an interesting suggestion. Shania says maintain a stack, put the operands in the order they appear when an operator appears, remove the top two elements, do the operation and then push the result back to the stack. Sure. Zeta has said push the, yeah, that is the answer to my previous question. Okay. Any other concerns? Any other comments, algorithms? Okay. So your algorithm seems to be on track, right? So in fact, the algorithms are correct. The except that this last part that we kind of discovered, that if an operator comes and it does not have enough number of operands available, then we can push the operator. Right? So this seems to be a little new thing. So let's understand that. So let's see if that is going to happen, right, in the postfix form. Shania says if operands are not available, push the operator and continue. Okay. Okay. So this is what I think where Kaustubh and Shania seem to be agreeing upon. Any other suggestions on this thought? Okay. So let's do this. We'll do a small exercise. I'll ask you for an expression where if you follow this algorithm, right, then you encounter an operator and you need to push it. Right? So can you give a valid expression where that operator needs to be pushed to the stack? So just to get you started, if I have 1, 2 plus, right? So the way I'm going to do according to your algorithm is that 1, push it to the stack, 2, push it to the stack. When plus is encountered, at that time, I'm going to remove these two elements from the stack and then going to add them according to the plus and push 3 to the stack. Right? So this is the algorithm that I'm going to follow. Now I want an expression, possibly a larger one, where when I encounter some operator like plus, the two operands are not there and the expression is valid. Yes, we are talking about only the postfix case. Yes, we'll come to prefix a little later. But yeah, for now, how is that possible in postfix notation is Mani Chandana's question. Okay, I think Kaustubh and Shania and possibly others who are agreeing to this should answer this. That's why we are looking for an expression. If it is not possible, then we'll come back and modify the algorithm. Okay, Saicharan also thinks that it is not possible. Okay, so let's understand why this could have happened, right? Can we use unary operators in postfix? Yes, you can do that. Not in our example where we have restricted it to plus minus star slash, but yes, in postfix form, you can have unary operators also. Murari says, I think it's not possible because at least two numbers before the operators are in pairs and hence can be calculated for a particular operator. Okay, so let's think about this. So let's say that you encounter a plus, right? And you don't have enough arguments available, or the operands are not available. So in our case, 1, 2 plus, right? Instead of that, if I write 1 plus, then the operands will not be available. But then the expression is also not a valid expression. So at least from that angle, Chotu Kumar says -1 plus 2, what will be the postfix for this? If you are talking about a unary operator, then we'll have to convert this as 1 minus 2 plus, and that minus needs to have a special symbol. It cannot be same as the minus binary. So minus binary and minus unary you will have to distinguish. Similarly, when you have plus plus operators, you'll have to distinguish those from the prefix and postfix form. Okay, but coming back to this, if you have plus, then it has in the postfix form, both the operands have to be appearing before that plus in the expression. And if you do not have enough operators, enough operands, that means that the expression is invalid. But then what is possible is that maybe one of the operands are present, but then the other one is an operator. So for example, I might have an expression which is like a sub expression which is like star 1 2, sorry, star 1 plus, where star is probably doing something on the previous part, right? So there might be 3 4 star and 1 plus, right? So when I encounter plus, at that time I might have, let's say, 1 which is just on the stack of the top of the stack, and then star may be there just below it. But then we said that we are evaluating the expression from left to right, and therefore when star was encountered, at that time itself it should have been evaluated and its result should have been pushed. Therefore, that result followed by 1 followed by plus, so then plus will have again 2 operands at least available with them. So now this indicates that we cannot have an expression where the case will appear where you are having an operator but its operands are not available, at least not in the valid postfix forms. And does that convey anything about the size of the stack that you require? Can we say that our stack size will always be bounded by 2 if all of the operators that we have are binary? Okay, Mani Chandana says no. Andrea says no. Shania says no. Good. So yes, that is not going to happen because as Pavan has given an example, 1, 2, 3, 4. I mean the operands can appear as many times as possible as long as those are followed by enough number of, let's say, n-1 number of, or number of operators, number of operands minus 1 number of operators, then that is okay, right? So the stack size will be bounded by the number of operands, and that can be arbitrarily large. However, the number of operators, I mean no operator is ever going to be pushed to the stack. only the operands are going to get pushed. Only the numbers are going to get pushed. No operators are going to get pushed, because as soon as an operator comes, we are going to evaluate it. Right? Saicharan says, for Chotu Kumar's question, can't we take A it as 0 minus 1 plus 2? Yeah, so you are converting from unary minus to binary minus, and then you can do that without having unary minus. Yes, that is possible. But I think what Chotu Kumar's question is, I think there are two questions there. One is um, minus itself can be ambiguous, right? So therefore, how do I distinguish? Well, we'll have to have different mechanisms or different mnemonics for each of them, right? So you can say one is minus, another is whatever, m or something, whatever, some character which will distinguish it from binary to unary. And the other one is that, can you represent unary numbers in postfix? Yes, that is also possible. Murari says, how to write post prefix if there are double digit numbers? Should we include brackets now? Okay, I'll come to that in a while. Aniruddha says we can use different symbol for unary and binary. Yes, that is correct. Okay, so let's agree to this, that it is not possible to have an operator push to the stack. And if you cannot push the operator to the stack in a valid postfix expression, then you never will encounter a situation where you have insufficient operators. Right? Does that seem reasonable? Anybody has any arguments against that? All right. So, but as you have already thought about it, that in the prefix form it might be possible. In fact, it will be possible, because when you encounter plus, its operands are going to come later. But how much later, that you don't know. Right? So the prefix evaluation will be a little tricky, and we'll have to think of something else. Okay. Now let's come to Murari's question, that if there are double digits, how do you represent those? So what I have shown are currently just single digits, and therefore I'm just representing it as a string. But if you have double digits, you will require some separator. Right? So either you can use space as a separator if you want to represent it as a string, or you can have the expression written as, let's say, a list of records or an array of records, rather than as characters. Right? A single character will always have this problem, that how do I represent double digits or large number of a large number. Right? So you would like the number to be represented inside the record, and then it is pointing to the next one, which says that okay, the next element is going to be this digit or this character, and so on. Right? So this I have shown only for exposition purpose. It's not necessary that everything can be represented using string. Or you want to represent string, you have those as separated by spaces, but then you will have to convert that number. I mean, 1, 2, 3, 4. If that appears, you'll have to convert it into actual 1234, like that. So for now, for making our life simple, we are just using single digit numbers. Okay. Then Saicharan says, for prefix evaluation, maybe we can pop when we encounter two consecutive numbers. We'll come to that, Saicharan. Don't worry. We'll do prefix evaluation also. Okay. Anish Kumar, can't we start reading the prefix expression from the end, adding elements in reverse order to the stack? Implementation would then be the same. Okay. So we'll probably come to this, Anish, your algorithm also, and Saicharan's question also. Okay, good. But coming back to the postfix, okay, Shreyas has a question. 1, 2, 3, 4 minus star plus can also be written as 2, 3, 4 minus star 1 plus, or this thing. Which one do we choose? Okay, so these are all optimizations, right? Because you are taking advantage of the commutativity, as we discussed yesterday, that commutativity or associativity will change the form of the expression, but it will change the form of the infix expression also. Right? And therefore, corresponding to an infix expression which is fully parenthesized, we have to maintain whatever is the prefix or the postfix version for that infix expression. Right? So we'll just use the first one. Is that okay? So for example, if we take the second one, 2, 3, 4 minus star 1 plus, then the infix expression corresponding to that will change, because we are not really taking advantage of commutativity, associativity, or other properties. So we will follow that without optimizations. Any other concerns, questions? Alrighty. So let's get back to our this thing, postfix evaluation. So this is what is the algorithm that you have given. Okay, whatever is the value of this, and that is what was our classwork. So the algorithm that you have given is for each symbol in the expression left to right. If the symbol is an operand, push its value to the stack. If it is an operator, then pop the two values because these are binary operators. Apply the operator and push the result to the stack. That's it. Right? That is the algorithm that I have. Now you have to tell me why this algorithm fails. The question is, you have to tell me why this algorithm fails. Popped nodes can also be an operator. Well, we just discussed that that is not going to be possible, right? But yeah, I understand what you are saying. So the argument here is that if it is a valid expression, then this algorithm is correct. Right? If the expression is not, because this algorithm is not checking for the validity, and therefore even so, for example, if the valid expression is a suffix of an invalid expression. For example, if I say that it is 1, 2, 3 plus, right? So there should have been two operators, but I'm just saying 1, 2, 3 plus. So I push 1 to the stack, 2 to the stack, 3 to the stack, and then plus adds 2 and 3 and pushes 5. So now I have 1 and 5 in the stack. The expression is over. I just declare that this is the value of the expression, whatever. What is the value of the expression, by the way? Right. So at the end, Saicharan says the stack should be empty, right? But where is the value? Okay, Kaustubh says length of stack will never exceed 3. Yeah, that was my question. That can you have just two operators, space for two operators, constant time, constant space operation like this? No, that is not the case, because you can have 1, 2, 3, 4 plus star slash whatever, and therefore you will need to push all of them. So length of the stack can exceed 3. It can be arbitrary, just that it can be maximum equal to number of operands, number of numbers in the expression. Saicharan says or have only one element, right? It won't be empty. It will have one element in the stack. Yes, Pavan says stack should have final value. Madhur says contain one element. Anish says just the result should be on the stack. Right. Only one element should be present on the stack. And if that happens, that means you are on the right track. That means you have evaluated the expression correctly. And that is the result of this expression. Right? And you can try that on the example on the slide at the top if you get exactly the same answer when you evaluate it in this manner. Right? Any questions on this one? Anything which is unclear? 11. Okay. Nikhil has evaluated it. Thanks. The answer seems to be 11. So please check that you are also getting. Okay. So if there are no further questions, let's look at the code. Right. So this is postfix eval.cpp. Again, I have some includes. Again, I think I don't know if C type is required or not. We'll see. But yeah, we require a string because that is the input. We require a stack. So currently, again, we are using the std stack, but you can use your own stack also. Either way should be okay. How does the main look like? Main is rather simple. It just says that I'm going to have command line arguments, right? So I can just pass the postfix expression as a command line argument, and I'll give you the answer to that. So what I do is that I create a variable expr of type postfix, right? Because I'm assuming that the input given is in the postfix form, and to that I'm initializing with the argument v of 1, which means that it does not allow, I think, spaces. or I don't know if you can give it in double quotes, but anyway, we'll try only with single digits without spaces. So the constructor has one argument. Constructor of postfix has one argument, which is essentially your character string. Using that, I'm going to store the expression. So now the expression is available to me in the class. What I do there now is I just evaluate the expression, and whatever is the return value, I just print it, right? So that is as simple main as possible. Let's look at the class postfix. Right, this is going to look a little different now compared to what we have seen for list and stack. I store the expression as a string. The constructor takes char star as an argument, and it initializes expr, that is the private variable here, with whatever is the argument passed. Right? So I'm initializing expr, which is of type string, with an argument which is of type char star. So this also invokes the constructor of string and so on. This same as doing expr equal to lexpr, right? So that is same as doing it here as part of the constructor argument. It is just a different syntax. There is a small difference that this gets invoked before the object is created and so on, but don't worry about that, right? So this is the same as that. Then there are two eval functions. One definitely is going to be called from main, right? That is what we have called without any arguments. And the second one is more fine-grained. This doesn't mean that it is recursive. It just means that I'm taking care of a particular plus minus star slash separately. So the algorithm exists inside eval, and evaluation of a particular operator depending upon the character C and the stack is going to happen inside the eval. And then there are some auxiliary functions like, is it a valid operator? Right? So that is, if it is plus minus star slash, then I just return true. Right? Any questions on the postfix class? Okay, Saicharan is asking what are argc, argv. Okay, so these are command line arguments. For example, when I do let's say you invoke a function a dot out x y z, right? So these are the three arguments that are passed to a dot out on the command line. So to access x y z, I need to access those using these command line arguments like argc, argv. Argc indicates how many arguments are there, including a dot out, and argv is actual list of those arguments. So it's an array of strings. So array of pointers, so each of them is going to be a string char star, and therefore so we can just check that. And for example, when I compile this program and run, then I have only one argument, that is number of args is 1, so argc is 1, and I don't have the second argument given. So using that, I'm giving the usage that I need to provide, the a dot out followed by postfix expression as the usage, right? So the number of arguments I have printed here as 1. So if you give some other argument, let's say 2, 3 plus, right? So it is going to now have number of arguments equal to 2. The usage is correct, and therefore it is going to evaluate that and then give the final answer. Okay, so now let's look at the algorithm. But any other questions here apart from argc, argv? So by default, main, we don't have any arguments, but it can have these two arguments. It can actually have 3 arguments also. Has anybody used 3 argument main? And if yes, what is the third argument? Okay, so then that is your exercise. Nobody seems to have used it. Find out what is the third argument in main, right? It has something to do with the environment under which you are running the program. But anyway, so coming back to our evaluation, right? So the eval function is going to be our algorithm, this without argument, which gets called from main. So that is making crucial use of this stack where we push the operands, the numbers. for each character in the expression. This is just a short form syntax, I think in C++11. But you can just go over the string as for I equal to 0, I less than expr.length, I plus plus, C equal to expr of I, right? So that is exactly what this is doing. If it is a digit, then I push it to the stack. What do I push? The stack is of integers, right? The stack is not of characters. So the original expression is in characters, but what I'm pushing is actually an integer. The reason being that although I'm using digits, its value might turn out to be more than one character. For example, I just say 92 plus, right? So then the answer is not going to be single character, it is going to be double character. And therefore I thought that having it directly added to the stack is going to be useful. But then the character C is a character, which means that it will have ASCII value of the number. That I need to convert into a number, numeric value. So if I say 0 inside the character string, its ASCII value might be, let's say, 48. Now that 48 will get pushed if I just do stack.push C, right? But I don't want to push 48. I want to push the value 0. And therefore I am just going to remove ASCII value of 0 from here, and that will make sure that whatever is the number, let's say 48 minus 0, 48 minus 48, that will get added, right? So this is not /0, this is 0, which means that this is actual digit 0, which has the ASCII value, some 48 or something, whatever it is. Again, don't hard code those ASCII values. That makes the life complicated for not only you after 6 months, but for others also. So instead of 48, we should use whatever is the appropriate one, ASCII value of 0. So that can be nicely represented as single quote 0 single quote. So use that. That's a good practice. Otherwise, if it's an operator, then I know that I need to evaluate that operator, right? So I just need those two elements from the stack. I could have as well popped the elements from the stack here and passed those arguments to this eval function. And whatever is the end result of that eval, this is the second function that we are yet to look at. Whatever is the end result of that, that number gets added to the stack. Otherwise, if there is any other space or even other characters, then I give error as invalid. Finally, the stack should contain exactly one element, and if not, I give an error. Otherwise, I just return the value which is popped from the stack. Right? So that is our algorithm. Any questions on this algorithm? Okay, there are some questions. Saicharan, can we do int C like in Python? No, int C will give you the ASCII value of that character. So it will still give you 40. In fact, you don't need to do int C also. You just use C, and that will be treated as in C. You can use in the programming language C. You can just use C, and that will be using ASCII value of that. So we can't use int of that. How can we use the same name for two different methods? Eval here is being used for two different functions. Eval. So as long as the signatures are different, it is all right to use the different functions having the same name. That is allowed in C++. That's called function overloading or polymorphism. In CPP, are functions and function argument 1 two distinct functions? Yes. Okay. Any other concerns? All right. So we'll move ahead. Now let's look at the actual eval function, which operates on two arguments, right? So this eval call is operating on the operator which is given as the character and the current stack. So I just need to know the two values from the stack. Right? So how do I evaluate that? Well, it just, if the stack size is less than 2, I give an error. Otherwise, I pop two values from the stack. Okay, this is also important. The values that you remove from the stack should be val2 followed by val1 and not val1 followed by val2, because these are in the opposite order. For plus and star, it will not make a difference because of commutativity, but for minus / it will make a difference, and therefore that one care one needs to take. and then I just print that value, and then I get the depending upon whatever is the operator, that is the character C, I just return the appropriate one. Note that these are integers, val2 and val1, because we have been pushing the integer values. Therefore, it becomes easier for me to evaluate it here. Right. So let's use our expression. What is that expression? Is it given here? No. I'll have to use the slide. I'll come back to the question. I think I will just use it from here. We'll also check if the answer given is correct or what happened here. Yeah, this is not copying. Okay, let me just enter it here. 5 1 5 1 2 3 star minus 4 plus 6 star minus 4 plus 6 star minus. And I think one of you had indicated that this should be 11, and we got exactly the same answer. And the intermediate steps are also written. What are the operators and what is the order in which it gets evaluated? So that is all mentioned here. Okay, so that is our expression evaluator. Let's come back to this question. Shania is asking, could you explain where single colon is used and where double? Single colon gets used only in, not only in, but in question mark colon, that is the ternary operator, which is same as if-else statement. Alternatively, I have used it in C++11 format, where when you go over elements of an aggregate, like a collection or an array, you can specify that for auto C colon, whatever is the aggregate name, right? So C colon expression, for example. That is one place. The double colon operator is a scope resolution operator. So that gets used when you want to say that a particular function is in particular class. This is the implementation of a particular function. For example, here, eval is inside the postfix class, right? So that is the scope. So I'm specifying that it is inside this class. Similarly, this one is not a class. STD is called as a namespace. Namespace meaning that I'm just putting the related things together inside. That is essentially called as a scope. So I'm pushing that into a namespace, all these variables which are, let's say, not variables, but declarations of vector, etc., all the STL classes, stack, etc. And then there are some objects like C in, C out, which are also part of the STD namespace. So there, again, the scope resolution operator gets used. There is another place where you can use scope resolution operator : for example, if I have a variable of type this int val2 here as a global variable, and I want to access that val2 here, so I can do : val2, and I can just use that in the expression, and that indicates that I'm accessing something which is a global variable, because there is another variable val2 here. So just to distinguish between that. So that is like a global namespace. So val2 is a global namespace which can be specified using without anything, and then : variable. Yeah, so these are the ones that I know are, : is scope resolution. So it will get used for classes and namespaces. Any other concerns, questions? Okay, there is a question by Shania. What about the line below public? Why is that a single colon? Line below public. Oh, this one. Oh, that is, yeah, this is another place where there is colon. Yeah, I missed that. Yeah, that just indicates that colon is a separator for all the functions which can be called as public and all the functions which can be called private, etc. Right? So,
no, sir, next line.
where? Oh, I see. Here. Oh, I see. Yeah, this one is more like an initializer, which is same syntax as saying expr equal to lexpr. So this is just one another. There is a reason why this is provided, but for now it suffices to understand that expr equal to lexpr is what going to happen if you push this statement inside the braces. So that is what it should do. That is just a syntax given for initializer, nothing specific. Okay. All right, so we have exceeded the time, so we'll stop here. If there are any questions, feel free to ask. Your questions remind me that I have not yet shared the link to object-oriented. I think this is the one. Yeah. Just those of you who are interested in learning C++ a little more, you can just go through some of the slides available here. I think at least some of that you should find useful. There are more complicated things like templates and other inheritance part, etc., which we are not going to require in this course. But out of your curiosity, if you want to learn, it's fine. Okay. So if there are no questions, we'll stop here. Okay, Anantu is a little early to the class.
Sir?
Yeah, go ahead.
Sir, one small concern. Sir, for the assignment, there was some late submission option. I had already submitted, but in the first submission, some hidden test cases weren't satisfied. So in the late submission, I tried to maybe submit again and see if it improves. Like I tried to modify the code, but it didn't. So my first submission will be considered, right?
Can you just drop an email, because the TAs might just pick up and overwrite your
So
number.
in the late submission, when I tried to modify something, my cases weren't improved. So finally, what happened is it just took 25% of my
I
initial
agree.
submission.
Yeah. We'll consider your initial submission only, but I just
Okay.
want you to just mail me so that I can inform the TAs about this particular case.
Yes, sir. I'll write.
Sure. And if this is the case with others also, please feel free to mail, and we'll. I'll anyway inform the TAs to take the max of the two, but in case they miss it out, then it might be helpful to have this mail as a record.
Yes, sir. Thank you, sir.
No problem. Okay, so we'll stop here.